Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Daniel Ismail and my metric number is 208078.
And my name is Ahmad Razif and my metric number is 208014.
Hi, my name is Dinesh Ravi. My metrics number is 207361.
Okay, so as a senior manager of a smart engineering solution company, I would like to know the progress of your new project based on the problem that you have been given. So the problem is when the carbon steel disc brake of the Satria Neo racing car that your group checked had a problem with the disc brake, as it always used the brake to decelerate during the racing. You guys have to make an analysis for the carbon steel brake and another two material which were cast iron and reinforcement aluminum matrix composite in order to choose the most suitable material for the disc brake of the racing car. And I hope you guys can explain well because we have to present it to the customer next week.
Okay, Dinesh, can you share my slide? So the part that was chosen for modification is Satria Neo 2000 brake disc. Material that is currently used in Satria Neo cars brake discs are carbon steel. So before that, I explain how the disc brake works. When the driver presses the brake pedal, the brake booster amplify and the force and the master cylinder convert it to hydraulic pressure. The pressure transmitted to the brake on the wheel via brake oil fill turbine. The piston on the four-wheel brake are pushed by the deliver pressure. The brake pad, which are made of the friction material, are pressed against the brake rotor, which rotate the wheel by piston. The pad clamp down on the rotor on both sides, causing the wheel to decelerate and the vehicle to slow down and stop. So that's all for the description of the disc brake.
Okay, thank you. Next, can you guys explain what method or technique that you guys use for the analysis of this problem?
Please, next slide, please. So to study the brake disc properly, the car was pushed to its limit braking. The plan was to accelerate the car from 0 to 26.8 meters per second at a rate of 0.5 meter per second. The vehicle was subject to the hard braking at -1 meter per second square once it reached 26.8 meter per second in order to reduce the speed to 13.4 meter per second. The track was designed so that the car takes approximately 3 seconds to complete the curve. This 3-second time slot was also taken into account in the numerical simulation of the phase of acceleration and deceleration. So the next step was to take the temperature reading using thermal camera because it is extremely sensitive to the temperature, and the diameter and thickness of the disc brake measured by caliper and rules. So that's all.
Okay, thank you, Nazir. Now, I would like to see the analysis of this problem.
Okay. Before the modification, three different material were chosen for the material for analysis, which is cast iron, carbon steel, and reinforced aluminum matrix composite. This material was chosen based on the mechanical properties, which is young modulus, density, tensile stress, and coefficient of thermal expansion. For the calculation, it can be done in two ways, which is during the braking, when the brake pads are pressuring on the brake disc, and after braking, there's no pressure on the brake disc, or in other words, the brake pad is released. Since our problem only focusing on the due to the expansion and causing damage to the brake caliper, our calculation will be only focusing on x direction, horizontal direction. The change in temperature is 874 degrees Celsius. Initial length is 0.02 meters. Air gap or distance between brake disc and brake pad before braking is 0.05 meters. And pressure, according to the Satya Neo service manual, the force given by the brake is equally in both sides, which is 7,755 meters. This is a free body diagram when the brake is applied. Elongation of brake disc is equal to elongation force 1 minus elongation force 2 plus elongation due to the temperature. Here we can apply the displacement due to the axial load. Since P1 and P2 are equal, we can eliminate the elongation due to P1, F1 and elongation due to F2. So we'll get elongation disc equal to uh, coefficient of thermal expansion times change in temperature times length of the brake disc. This condition goes for after the braking, where so only elongation of temperature involved when there's no pressure on the brake disc. After the calculation, we can get the final length of the brake disc for cast iron is 0.022199 meters. For carbon steel is 0.022235 meters, and for reinforced aluminum matrix composite is 0.2235 meters. That is from me. Thank you.
Okay, next, you may proceed with your discussion.
Okay, based on the calculation, the major criteria is actually the overall deflection. In case of breaking two brake pads, it is forcing the dies from two opposite sides. As the material should have low coefficient of thermal expansion, so the elongation value is low, and besides it should have high tensile strength. In comparison, aluminum matrix has moderate tensile strength, and elongation is the highest among all, while carbon steel has the highest tensile strength, and elongation is lower than composite but higher than cast iron. Cast iron has the highest tensile strength, and elongation is the lowest. Based on the comparison, Young modulus value of any material is not playing any significant role. Now, tensile strength is maximum for cast iron and elongation is the lowest for cast iron. So the cast iron has the best property to meet the requirement. From the result, a final conclusion can be drawn that for the application of this brake, the cast iron is the best material among all three materials. Next is the reinforcement aluminum matrix composite, and lastly carbon steel. That's all.
Okay, thank you. Okay, now let me complete what you guys just presented. I think you guys just choose cast iron as the most suitable material for the disc brake of the Satya New Racing car compared to the other material. And this is because I think cast iron has the lowest final length and the coefficient of thermal expansion. Besides, cast iron also has the highest tensile strength among the other material, which means it can withstand longer while being stretched or pulled before it breaking. And for your information, I approve this project for the next week customers presentation. So good luck and well done, guys. Thank you.